University Teknologi Mara Perak Malaysia, yaitu Dr. Muhammad Imran yang nanti akan memberikan materi mengenai file management. Ya. Jadi Dr. Imran akan share mengenai file management selama kira-kira 1 jam. Ya. Nanti setelah Dr. Imran selesai baru kita lanjutkan materi yang kelas kita. Oke, untuk selanjutnya Mr. Imran, silakan Mr. Imran, bisa dimulai.
Yes, Assalamualaikum. Boleh dengar saya?
Waalaikumsalam. Dengar?
Okay, nanti. Okay, alright. Thank you so much for the introduction. Pertama sekali, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, today saya akan memberikan lecture. I will give you a lecture on file system. Okay, under the topic of operating system. Okay, please be, if you have any questions, you can just stop me. You boleh tanya melalui chat ataupun direct, terus boleh tanya saya, tiada masalah. Okay, so shouldn't be any issue. Apa yang saya cuba sampaikan di sini ialah topik yang sama juga yang saya mengajar di kelas saya di sini, which is under chapter 2. Tetapi I think over there is in chapter 7, saya kira. Okay, 7 also. If you have any questions kalau dalam bahasa Melayu atau bahasa Inggeris, boleh go ahead. Okay, I hope you all can hear me. Semua okay? Kalau boleh, kita mulakan sekarang. Okay, alright. So what we'll do today is we will be talking about chapter 7. File system. Okay, so we'll be talking about understanding file system, the concepts, the access method, and also the directory structure. Okay, the directory structure. Dan saya akan bagi satu atau dua slide yang hopefully it can cover the whole of this chapter. And untuk makluman, saya sudah upload slide ini di dalam BINUS e-learning management system, so you can access the slides from there later. Okay, so seterusnya, this is just a little bit introduction. Ini nama saya. Okay, my email address, and I come from University Teknologi Mara Perak, campus Tapah, Malaysia. And campus Tapah, this is a branch campus, kira-kira dalam 2-3 jam daripada Kuala Lumpur. So let's talk about file system. It's a mechanism for storing, catalog and retrieve set of names of files and the directory structure into which they are organized. Okay, so what does all this jargon mean? Okay, so what we need to understand in the file system under operating system, the operating systems provide a mechanism for the users of the computer, of the PC, to store, catalog, and retrieve set of files. Okay, so the user needs to only copy in the file, letak dalam PC, and the operating system will store it for you, will catalog for you, and you are able to retrieve these file system based on certain condition. Okay, and these files are obviously format only the operating system can understand. Okay, and the operating system also provides certain type of access to certain types of file. Ada access yang boleh view only, ada access yang boleh write only, ada yang boleh read, or either you can have view, read, and write of the file. And this is some kind of file protection. So what does a file mean? A file means it contains data. So dalam satu file, it contains data. For example, if we take we take a simple example, let's say you are working on a Microsoft Word file, .docx. So dalam file itu, you have some data. Okay, the data can be any kinds of data which is inside that particular file. Okay, and then you can update this data, you can delete this data. And once you have deleted or updated this particular file, you resave the file inside your hard disk, and the operating system will help you to restore the particular file. And the operating system also provides metadata about the directory structure. Okay, and for example, who created the file, where is the file stored, who was the last person to access the particular file, and who can access the particular file, and so on and so forth. Okay, in this lecture, file system, we are going to use two terms yang awak mungkin akan selalu dengar, which is the directory and the folder, and file. Tiga. So directory, folder, and file. So these will be the three most common terms that you'll be hearing inside this chapter. Okay, so a little bit about directory first. Directory in Windows operating system is defined as the location of all the files and folders. So you have directory C, directory E, F, and so on and so forth. Okay, so that is a directory. However, a folder is a location inside the directory which compiles all the files about the user or anything else. Okay, so the file is the smallest entity and the biggest entity is the directory. But sometimes along the lecture, you will see we use the term folder and directory together. Okay, so you will hear these terms quite often in this lecture. And also we have the operating system, so also allows users to have partitions in your PC. So what does partition mean? So partition means you divide your hard disk into specific size. Normally you have the primary partition whereby the operating system sits inside a primary partition, and then you can have up to 4 primary partitions. So when we are talking about primary partition, bermaksud you can have 4 operating system in your PC. However, at one point of time, you can only run 1 operating system. Okay, so primary partition, the job is to have the operating system sitting inside. Okay, so maximum you can have 4 primary partition, but you can have 1 primary partition and a few extended partitions. That means you can have C for your Windows, D for partition number 1, E, F, G, H, I, J, K, and so on and so forth. Okay, and you can specify the size that you are looking for in each partition. Okay, next, let's look at this slide. The next 2 slides is a simple overall, a simple overall summary of the topic that the chapter that we are talking about today. So we are going to cover file directory. Okay, so this is the explanation, and what can a file directory do? Okay, and what types of file directory is there available by the operating system. So we are going to learn about single level directory, 2-level directory, 3 structure directory, and a cyclic graph directory. Actually, there's one more that we will cover along the slides. But this is in general, these 2 slides, this one, yang ini dengan yang ini, is the overall about today's lecture. Okay, so let's first go through what is file directory. Okay, a file directory is talking about physical disk which can be broken up into multiple partitions, like I explained just now. So you can have one directory broken up into a few directories here. Okay, so this example is what we say is a multiple partition. So you have a directory A, and this directory A contains certain files, and directory B contains certain number of files. Or if you are not interested, you can have just one partition, and you can store all your files and folders inside one partition. There is not a problem there. Okay, so operating systems will help you to create this partition by you specifying, the user specifying the size of each partition. Okay, next we also have the search function, the create function, delete, list, rename, and transfers a file. These are all operations provided by the operating system for each of the directory. So when we say directory, operations on directory, means these operations, search, create, delete, list, rename, and transfers, can also be used by anything under each directory. Let's say in directory A, you have 10 files here. So all of these 10 files, you can search for the file, you can create a new file, you can delete a file, you can list down the directory, you can rename, and you can transfer the file system. I won't cover transfers. I will show you in another slide what actually you mean by transfers of file. But search a file is quite simple. You know how to search a file. How do you search a file? In Microsoft Windows, when you have a GUI, you just maybe sometimes use Control F, or you have a taskbar, a search button on top, and so you can use that. Or how do you create a file in a Windows operating system? Simple, right-click, new file, done. How do you delete? You click on the file, you press button delete, done. Or you right-click, delete, done. How do you list a directory? You double-click on My Computer, or you double-click on your File Explorer. You can see everything about the directory. How many files, how many subfolders, how many hidden files, and so on and so forth. How do you rename a file? Again, very simple. You right-click on the file, rename, and so on and so forth. So that is how you rename a file. But in the older operating system, I would say, let's say we give you an example of MS-DOS. Okay, DOS operating system. There was no GUI, so you have to remember the commands, and you type in the commands, and this operation will take effect. For example, if you want to rename a file, you have to type a certain command on the screen, and this command will automatically change or rename a file. Okay. Next, we look at how these files are stored in the operating system concept. Okay. So in the olden days, olden, I'm not saying so old. I'm talking about in 20 years ago. In the 80s, we used to have only a single level directory system. What is a single level? This show here. Okay, you cannot do any partitions, and you have only one user to the PC, meaning you cannot have multiple users to the PC. You only have one user, and each directory has multiple folders. Okay, multiple folders here, and each folder has one file only. Okay, one file only. So the disadvantage here is whereby you only have one user and one folder, one file, and there cannot be a file name which is similar to another file name. Okay, so each file must have a unique name. Okay, so if, the biggest disadvantage here is whereby you will have so many folders. However, in each folder there's only one particular file. All right, so you can just imagine you have all the yellow boxes in your C drive, and in each yellow box there's only one particular file. If you put in a different example, let's say you're taking this course of operating system, and you create a folder, and you put your assignment in each particular folder respectively. Okay. Next, next we moved on to about 1990s, or what we say is multiple users, multiple people who can actually use the PC. Meaning you can log in as your name, and then once you are finished using the PC, you log out, and then I can log into the PC, and I can see what my files are. I can only view my files. I cannot view your files, even though we are using the same PC. But in this architecture, you will have the same files repeated, or the same folders repeated in different users. So you will have, for example, I am user 1, you are user 2. So when I open the PC, I will see a folder called My Documents, and inside My Documents, only files that is relevant to me and my pictures and so on. But I also will see a folder called Windows, which is replicated in all the users. Okay, so the biggest disadvantage here is you will have the same folder repeatedly copying in different places. Okay, especially the system folder, which is the Windows operating system folder being copied in user. So this, by copying the same file over and over for different users, this will actually eat up your space. So that was the biggest problem in two-level directory. Next, you will move on. They used to have something which is called the tree structure. This was 95, 97 well. So what does this do is basically you will have each user can create their own subdirectory and organize them themselves. Okay, so in this concept, you can have each user. You still have multiple users, but each users can have their own subdirectory, and this subdirectory cannot be seen by other users. Okay, so this was a bit more advanced, whereby you can have the file name, similar file name, because you come from different users. However, the biggest problem was if you were to do a search, you can see other file names as well. For example, if I search F1, I can see a few F1s because it comes from different users, but I cannot access those files simply because I'm a different type of user. Okay, next we go to acyclic. Acyclic is also when the same file needs to be accessed in more than one place in the same directory. Okay, in this situation, sometimes you have a situation whereby the same file needs to be accessed sometimes by multiple users. This is an example of, let's say you are doing a sharing of a file. Okay, a sharing of a file between multiple users, or maybe you are sharing. You want to access the file in more than one place, in the directory structure. For example, in this acyclic graph, we are talking about shortcuts. Okay, shortcut files. For example, let's say you save the file inside your thumb drive, which your thumb drive directory is E, and inside the thumb drive directory is a folder called testing.123. Sorry, testing. So this inside the thumb drive is your file. So sometimes you are too lazy, or you find it so difficult, you have to double click a few times in order for you to access your file. So what you do is you copy the file, and then you make a shortcut link on your desktop, and the next time when you want to access that particular file, you just double click on that particular link on your desktop, and automatically it accesses the same file which is inside your USB. So that is much more simpler. So acyclic graph directory talks about, we are talking about what you say, shortcut links that makes it much more simple to access. Can you all hear me? Am I okay? Am I going too fast or too slow?
Sir.
Okay, thank you. All right, next. Okay, so this is what I've been talking about. How does it look like? So you have a directory here, and this directory is broken down in the first part. The first part. on the left-hand side here, we are talking about two directories here. So you have two partitions, or you can have one big partition, the diagram on the right. So it depends on how the user wants it. Okay. So what is a file? Again, we just go through again. What does it mean by a file? A file is a collection of binary, numeric, or character. A file could be a program, a document, or in some parts, part of the file system. So what does it mean by part of the file system? For example, if you are doing Java programming, .java or .c++, .cpp. So when you compile your particular file, you will have a few other files together in order for you to compile the file. You have your dot input, output, and so on and so forth. So those are part of the file system. And you can also say a file is also a program. For example, a simple program, Microsoft Word, Excel. So those are programs. So those are also considered as a file as well. Or a file can be a collection of binary, numeric, and character data. So Microsoft Word is a very good example. So inside that you have a numeric data, you have characters, and so on and so forth. So those are also file, is defined as a file. Okay. Point number 2, can be stored in various media. Yeah, quite simple. You can store it in your USB, you can store it in the cloud, you can store it in your hard disk, and so on and so forth. Let's say, and the last point here, point number 6, all files have a name. Yes, obviously, that is quite obvious. Semua file perlu ada nama. Okay, so you need to have, each file needs to have a name. So it's divided into 3 parts: the unique file name, period, and extension. So example, let's say testing, unique file name, testing is the unique file name, dot, period, and extension, testing.docx. So docx is the file extension of that particular file. Okay. All right. So what properties or attributes does the file have? Obviously, it has a name, identifier, only for the operating system to identify which is the file. What is the type of the file? Is it a JPEG? Is it a PDF? Is it a Word document? Is it a HTML? Where is it stored? Is it stored in location? Which location is it stored? How big is the particular file at the current moment? Protection. So these are the attributes provided by the operating system for each of the file. So the application, who access the file, at what point did you access the file, and so on and so forth. And the operation system also allows, as I explained now, for us to create a particular file, write on a particular file. So you can create, how do you create? Simple, you can right click, create a file, new file. You can open PowerPoint and you can say new file, okay, you can do that. Or you can just open a new Excel and just create a new file. Next, you can also write to a file. How do you write to a file? Ini sangat simple lah. Okay, so you open the file, you edit the file, and so on and so forth. Okay, how do you read the file? Again, okay, when you do a search, the operating system will read for you the file. Will read in this manner does not mean you open your Microsoft Word and you read what is inside. Read in this manner means that the operating system finds the particular file and reads on the file so that it can appear on the screen for you to look at. Okay, that is what it means by read, not the read that we understand. We double click the file, buka, tengok, and terbaca. Bukan itu. Okay, read means where the operating system goes and locate the file and reads where is the particular file and makes this file available on the screen. Okay. We can also, the operation system can also do a file seek. File seek means, what is it? It means it's something like a file search, and then it can look for the particular file, it can seek on the particular file, you can delete. I mean, I'm sure all of you know how to delete a file. Okay, truncate. What does the truncate mean? Mean operating system can allow for truncate, allows this operation, okay, whereby the contents of the file can be deleted, but the file is still open. Okay, the file is still available. Okay, this is, for example, like you have a Word document, a Notepad file which stores in certain information. However, certain period of time, you delete this information and you store this file with the new information, or maybe you just delete this information. However, the file is still the same. So maybe the contents keep changing day by day. Okay, this is normally useful in certain factories, especially whereby they need the information about maybe the connection time, the response time, or if the network goes down, what is the error message or anything like that. So to be kept in a certain location, to be kept inside a Notepad file, so that they can automatically access this file whenever they need it. So this file will be automatically keep the latest information about that particular file. So it truncates the old data and puts in the new data. Okay, so operation system can do that and can also perform appending, renaming, and copy and move. So the easiest is how to move a file. I'm sure all of you know. You drag and drop, or you copy, cut, paste. Okay, so it goes the same way as a copy. How do you rename a file? Senang sekali. You right click and and how do you append a file? You append means you change the information about the file. Let's say the information, let's say in the particular Word document file, you have about 10 pages. So you want to append on that file, meaning you add another 10 pages, you add information, you add data to the particular file. So operating system allows you to append on a particular file. So what are the types of file? Ini senang lah. Okay, these are the types of file available. Okay, so these are types available. Or examples. Okay, you have HTML, you have an MP3 file, you have, what else do you have here? You have MP3, PDF. These are all some of the simple examples that you normally you have used. Okay, so now we are looking at how does the operating system access each file. Okay, two types of access method that we are going to understand. One is the old access method, which we don't use, but we need to look into it, which is called the sequential access. Another one is called the direct access. Okay, before I continue, I have to ask this question. Have you all seen what is this before? Do you know what is this?
Tape.
Bagus. Thank you, Akmal. Nasib baik you jawab. So that does not make me feel old, because in previous lectures, some students ask me what is that. So at least Akmal, magnetic tape. No, it's not a magnetic tape, Jonathan. Yeah, sometimes it's called a magnetic tape, but this is just a cassette. It's not a cassette player. It's a music. I mean, tape is not a magnetic tape actually. Magnetic tape is the VHS. Okay, so this is a normal music tape. Okay, and I can still remember my first band which I bought. Tape. This was 10 years ago. I hope you can remember what was the first tape that you bought. And is it still available in Jakarta? This tape? Do you know where to find it? Normally, they'll be selling this in the old any malls. They'll be selling. So I have a music tape that you bought. Okay, so at least Jonathan pernah, Akmal tahu, Jonathan tahu, Carolus tahu about tape. Alhamdulillah. Okay, all right. So tape. So this is the simplest example I could come up with. So basically, this is how the operating system works at the olden days, whereby it accesses the information sequentially. Sequentially means one after another. So let's say it wants to access location number 5. So it goes through location 1, 2, 3, 4, and 5. Okay, one after another. Okay, and let's say there is an empty spot in spot number 6, and he wants to save the new information. So it has to go through one by one after another, and reaches number 6 for it to save the new information in location number 6. Okay, that is a sequential access. So point number 3, this is where the information in an access file. This is where the information in a file is accessed from the beginning one record at a time. Okay, so in order for it to retrieve the records in location number 8, it has to go through location 1 first, and then 2nd, and then 3rd, 4th, 5th, 6th, and 7th. And finally, it reaches location number 8, and only then you can access the file. Okay, that was the older method. But now we have, now we have the new one. I mean, all of us are using is what we say the direct access method. So the direct access method is whereby users are allowed, the operating systems allow directly to access any location in the file system. Okay, so meaning if you are looking at location number 5, so obviously straight away you can go to location number 5. The operating system will straight go to location number 5 and give you the access of location number 5. Okay, so point number 3, direct access is better suited to most applications than sequential access. Yes, correct. So now that's why we don't use sequential access anymore. It's more direct. So straight away you can go to the particular example. If you want to listen to song number 5, you have to go through song number 1, 2, 3, and then finally you reach song number 5. But now with the direct access method, if you want to listen to song number 5, you automatically go to song number 5 and you listen to it. So it's quite simple. So in the programming, how do you program? So next, and then we reset, and then we continue this until we find an empty spot. If a direct access, how do we do it in programming? You read n. N is the block that we want to read. Or we write n. N means an empty block. So obviously it will read, or obviously you have to specify which block, and straight away you can access that particular block. Okay, so this slide is talking about the programming version. Okay, so overall, how does our directory structure look in an operating system? This is how our directory structure looks. It contains file name and identifier, point number 3. And then it stores information about all files, point number 1. And you can see there are a few folders all attached to one directory. So in this picture here, we are talking about one directory system, but having multiple users. So why do I say multiple users? As you can see here, you have user, and then you have this folders similar as this one as well. Okay, so what is the difference between this user and all users? So all users is normally under the administrative mode, and it will keep track of all the users. However, this username folder is normally given to each particular. So if there are 4, and each of these users will have a separate folder for themselves. Okay, so as you can see, there are 1, 2, 3, 4. These same folders are also repeated here, and it's going to be repeated for each of the users. Okay, so what direction of the folder? Okay, where is it stored? So what is the size of this particular folder, and what does it contain? Okay, and then maybe you can also look at the security, which talks about the protection information, and you can look at the previous version tab. It talks about the date, last access, and everything else, talking about the date. And maybe you can look at the sharing. Maybe you want to do some protection, you want to share this well, so you can click on this particular tab. Okay, next you can also perform a list. Okay, a list of a directory, meaning you just double click and then you see all the information about your particular folder. Normally we click on your file explorer and then you click on a particular folder or directory, and automatically you can see all the folders in that particular directory or folder. Search, as I explained to you just now, you just use the search button, tap on the right at the top of the screen. How do you create a file? Again, right click, or sometimes if you're using MS-DOS, you need to know the commands. Okay, delete and rename. Okay, transfers. This is what I would like to explain to you. Transfers mean you are able to view the files and the directories, but you are able to look at all the directories and all the folders in one view. So transfers means the user is able to view all the folders and files in one screen. So operating systems allows this. Okay, but sometimes you can have minimal view simply because you are not the administrator. Okay, so if you're using MS-DOS, okay, so we have in MS-DOS a command called dir. So by user typing this command, the files related to that particular directory itself. Okay, so the command is dir, which stands for directory. Okay, so yeah, operating systems allows you to organize a file, to name a file. So when now you can name a file. Two users can have the same name in different files, in different folders. Same names can have several. Same file can have several different names. It's possible. Okay, same file. Okay, you can group the files. Your operating systems allows this. You can just, if you're looking at your Windows, again, you just have right click and everything appears. Okay, next, we are also looking at, as I explained just now, how do you organize this? You can organize this through the operating system says in the olden days you have single level directory, you have two level directory, and you have tree structure directory, cyclic, and graph. Okay, so as I covered this now, and I will go into detail now. Okay, single level directory is whereby you have no users, you have only one user, and you have only one directory. Sorry, you have one directory for each particular file. So this is your directory, or what we say is folders here, and this is your files. So the problem is you cannot do any grouping. What does it mean by grouping? You cannot, let's say these are all PDF, or maybe these are PDF, maybe this is Word document, PowerPoint, and so on and so forth. But if you're doing a single level directory, you cannot group them together, meaning you cannot find out the number of PDF files you have in your system, because the grouping can only be done under a particular directory or particular folder only. You cannot combine the other files from other directories. Okay, a two-level directory talking about multiple users. Okay, this is the example. I've given you a picture here. So we have two users here. Okay, these are two users. So again, so each user is given a set of directories to use. Okay, but again, you do not have grouping, but you can have grouping inside of one user, but you cannot have grouping between other users, because let's say this is this one here is PDF, and this one here is PDF, and this one here is PDF, and this one here is PDF. So you cannot, when you do a search to find out the number of PDFs, you cannot get 4 PDFs, because the search is only done based on the user directory itself. Okay, so each file under the two-level directory, each file has a path name. Okay, a path name meaning it's this file, this direct folder belongs to this user. Different users can have the same file name, yes. For example, this one here is testing.html. This one can also be testing.html. This one can be testing.html. Searching becomes more efficient as only one user's list needs to be traversed. Traverse means you are able to look at all the systems. So if you search a file here, or you search a file here, you are able to get the results only here. You cannot take the search from here or here. Okay, so if you are user 1, you can only search within your user 1. The same kind of files cannot be grouped together into single directory for a particular user. No, you cannot group the files because they are in different types of user. Okay, so we have the path name. The path name means what is the exact path name for this particular file, because this file is now stored here. So the path name will be file entry, and the next path name will be user 1. Okay, so we are going to cover this in the next few slides. Okay, disadvantage of using a two-level directory, since the file name would be searched in the current user file directory, the system file needs to be copied to each user file, meaning in each user file directory, you will have the same Windows operating system folder, the same Windows operating system folder, the same Windows operating system folder in each of the UDF. UDF stands for user file directory. Okay. All right. So this is an example of the system files. So you have program files and Windows. So these are system files. So when you have multiple users, you will have the same thing copied to 3 different locations. Sorry, not 3 different locations. 3 different users. Okay, so in different locations because it's all the same. So that is the disadvantage of the two-level directory system. Next, we go into the tree structure. Tree structure means again multiple users, no problem. Multiple folders, and each folder can have a subfolder and can have a subfolder. No issues there. So how does the tree structure look like? Basically, it looks like this. This is what we are using now. You have multiple folders here, and each folder has also another folder, and it goes on and goes on. Okay, tree structure can a generalization of 2 level with each user has a current directory. Okay, the same as the 2 level. Can change the current directory via CD command or system call. Okay, system call is whereby you double click on the, if you are running on the GUI interface. But if you are running on an MS-DOS operating system, so you will use the command called CD, change directory command, because you want to change directory. Let's say now you are in folder A, and then you want to move to folder B, so you have to change the directory in order for you to move from directory A to directory B. And the path name can become absolute or relative. So I will explain to this later. What is absolute and relative? Absolute means the actual file name from the start. So this is inside C. Inside C, there's a user folder, Shama, desktop, and this is the particular file you are looking for. So this is called the absolute. But in a relative path name, the operating system only keeps the second last or the current CWD means current working directory of the 1 level up only. So in a relative path, the operating system only keeps the 1 level up path name only. Why is this good? If we copy this folder into a different directory, this folder can be accessed no problem, because it only copies the directory above that, but whatever above that can change at any point in time, so no issues. But if in this absolute path, when you copy over, the file needs to go on this particular path only. You cannot change. Okay, you cannot change any path name or any path relating to the file. Okay, so the tree structure directory, we can do grouping, much more efficient in searching. Yes, we can search. And certain commands that you need to understand. How to delete a file in MS-DOS, you use the command called rm. Okay, even in your Windows operating system, you can go into the DOS program. You just go into your start button, just type command cmd, and you will get into a dark screen. And in the dark screen, you can type these commands and it will work. Okay, If you want to create a new directory, you just type in the command mkdir, mk space dir. Dir name stands for any name that you want. Let's say you put in testing, and obviously you'll see the folder testing appearing. And if you want to delete a particular file or a particular folder, so you use the command called rm, remove. Okay, remove. So those are that. So this is some examples of using the command. Next, we go into a cyclic graph directory. Okay, so you have the same thing, but we are looking at what we say as we are looking at one folder pointing to another folder, which points to a few folders. For example, W points to this folder, but at the same time, words also points to this folder. So you have two folders coming in. So a cyclic is normally talking about link. Okay, shortcut link here. Okay, let's say we want to access this particular file. Okay, this particular file. Okay, so this particular file in origin by default is under the the folder called ALL. Okay, so we want to access this particular file from list and from Word and from W. Okay, so what you do is when you go inside this folder, or when you go inside this folder all, you make a shortcut link for this file, and you place this file inside this folder, and this folder. So automatically, when you double click the file, it refers back to this one over here. So that is what it means by a cyclic graph directory. So you make a shortcut link because you want to share a subdirectory or a folder. Okay, so these are certain key points that you can understand, you can read. And so point number 4, if directory entry is marked as link shortcut, name of the real file is included in the link information. So this file's name is suggestion. Suggestion shortcut, meaning but you keep only the shortcut link, so that when a user clicks on it, it automatically reflects back to the original location of that particular file. Okay, so these are certain diagrams that you want. Okay, next we are also going to look at mounting. Mounting is a concept that is normally used. You can see it actually in that particular drive with your operating system. Okay, so in Windows operating system, when you're using the PC, you actually have to mount your drive, your hard disk, your thumb drive with the operating system. So what does mounting mean? Mounting means that you provide a link between, or provide a link between the file system and the operating system. Okay, so the operating system will create a link so that now you can access your hard disk. Now you can access that storage system for you to gain any program or anything inside that particular device itself. Okay, so mounting, normally you can also unmount that particular location. Okay, unmount means when you unmount that particular location, you are actually breaking that link. So when you break that link, it's as if you are pulling out your thumb drive from your PC, so you cannot access that location anymore. Okay, so I think my time is up. We have another 2 more minutes. Let me just go back to the first two slides. Okay, so again, I would like you to highlight on these 2 slides. Okay, so what does it mean by find directory? So the information is there. Okay, what can the directory do? The information is here. The directory can do a search, create, delete, list, rename, and transfer. Types of level access method. So we have the single level directory, we have the two-level directory, we have the tree structure directory, we have the acyclic directory. So these are certain examples. So these are what we have covered today. Always remember, if you're talking about acyclic, we are talking about shortcuts. And if we are looking at tree structure, we are talking about the absolute path and relative path. So we have a path name for each of the file here. Okay. So if you are talking about two-level directory is talking about multiple users to the operating system. Okay. And a single level directory is whereby we are talking about a single user to the operating system, and each file needs to have a unique name, and you cannot have a same file name in two different locations. And this is an example of the partition. So on the left hand side is what we say as the multiple partition, and on the right hand side is a structure where we have no partitions. Okay, so I think my time is already up. Thank you so much. And if you have any questions, please feel free to ask me now. Maybe I can take one or two questions. If you have any questions, you can ask me on the chat room, or you can just on your mic.
Any questions? Feel free to unmute yourself, or you can also type in the chat room. Any questions?
Okay, do you have any questions you want to ask me? Feel free, no problem. You can ask me, or you can just email me later on. Again, my slides are available at your Pinus learning management system. So you can take the slides and you can look into it. If you have any questions later on, please feel free to email me, or you can just WhatsApp me. My number is there. Yeah, should be no problem. Okay.
Okay. Thank you very much, Dr. Imran, for your sharing today.
Okay, thank you, Shanti.
Yeah.
Imran.
Pak Rubio?
Yes.
Yes.
Okay,
I think the time
Okay,
is
terima kasih.
Thank you.
Okay,
Probably one announcement for me, for the students. I will give you an extra ticket for the seminar to get an SAT points. So please fill in the form as soon as possible, because I will limit the form to be filled in only for the next 15 minutes or so. Yeah. So please make sure that you fill it up as soon as possible. I will type it in the chat room. So, Pak Rubio, the time is yours now, Pak. Thank you very much.
Okay, thank you, Bu Giovanni. Oke, selamat siang semuanya. Suara saya kedengaran? Halo?
Dengar Pak.
Dengar Pak.
Ya, ini kita masuk ke session 10 mengenai memory management. Ya. Oke, kenapa memory management itu penting ya? Kita lihat sekarang saat ini di mana harga memori sudah relatif murah, terus di mana aplikasi juga butuh makin lama makin butuh memori yang banyak, ya. Jadi memorinya murah, ya, tapi aplikasi makin lama makin butuh memori yang banyak, di mana kadang kebutuhan memori itu tidak mencukupi dari kebutuhan sebuah aplikasi. Ya, jadi sehingga diperlukan suatu manajemen untuk kita bisa mengatur penggunaan memori. Ya. Jadi kalau kita lihat di sini juga memori itu dibandingkan ya, dengan CPU, memori itu relatif lebih lambat. Ya. Jadi oleh karena itu kita butuh memori manajemen di sini. Ya. Sekarang kita lihat di sini memori manajemen itu kita butuhkan agar kita bisa mengalokasikan sebuah tempat ya, untuk sebuah proses bisa dilakukan. Ya, jadi di pertemuan pertama kita belajar bahwa semua proses itu sebelum akan masuk ke dalam sebuah prosesor, dia akan diletakkan di dalam memori. Jadi diambil, ditaruh di memori, baru nanti dimasukkan ke dalam, dilakukan proses oleh prosesor. Ya, jadi si memori manajemen ini akan memastikan bahwa proses itu nanti cukup nih di dalam memori ukurannya. Jadi tidak ada proses yang tidak bisa diletakkan ke dalam memori. Maka diperlukan namanya memori manajemen. Oke, sekarang kita lihat kebutuhan memori manajemen itu. Pertama adalah karena relokasi. Ya, kita tahu bahwa ada kalau memori kita kecil, ya, kadang memori itu dia swap in swap out. Ya, jadi masuk keluar masuk, terus nanti ada datanya ditaruh di virtual memory. Ya, jadi nggak semuanya ditaruh di memori, tapi referensinya aja gitu. Nanti referensinya untuk di reference ke virtual memory. Nah, jadi proses dia swap in swap out, ya, ambil dari logical ke physical, itu namanya relocation. Nah, jadi biasanya kalau kita melakukan mengcode suatu program gitu, kita nggak tahu nanti program kita mau taruh di memori mana, mau kita letakkan di dalam address apa gitu. Jadi oleh karena itu harus ada memori manajemen di sini. Ya. Terus yang kedua adalah protection, ya, di mana protection itu adalah yaitu memprotek sebuah reference memory location supaya tidak bisa digunakan oleh proses lain tanpa permisi. Ya. Jadi dia mengatur bagaimana memori address yang sudah digunakan oleh suatu proses itu tidak dipakai oleh proses lain tanpa ada permission. Ya. Jadi itu fungsi dari protection. Terus yang ketiga adalah sharing, di mana kita bisa men-sharing memori untuk beberapa proses. Ya, jadi 3 proses nanti dia sharing penggunaan memori, memori address yang sama. Nah, ini dibutuhkan namanya memory management gitu, untuk mengatur bagaimana proses sharingnya itu. Ya. Oke. Selanjutnya adalah logical organization, ya, di mana proses logical ini kita memberi memori itu alamat logik, jadi nggak alamat fisik, jadi referensi aja bahwa nanti dia akan mapping ke fisiknya sekian, jadi diberi alamat logical. Jadi penggunaan memory management ini adalah kalau kita nanti menggunakan logical organization, nanti kalau kita berhubungan dengan virtual memory, ya. Jadi kita ada memori data yang kita letakkan di dalam virtual memory, ya, referensinya kemana, itu nanti memory management itu yang akan melakukan proses tersebut. Ya. Terus yang selanjutnya adalah kebutuhan memory management adalah karena physical organization. Ya, ini adalah di mana memori proses itu kita letakkan address-nya secara fisik. Ya, jadi alamat memori itu fisik. Ya. Tapi di sini ada jika program dan data itu tidak cukup, ya. Jadi misalnya memorinya hanya 1 mega, sedangkan kebutuhan proses lebih dari 1 mega, ya. Di proses plus data itu lebih dari 1 mega. Jadi dibutuhkan nanti namanya nanti ada teknik namanya overlaying. Jadi nanti dibagi-bagi per proses itu bermodul, gantian tuh sweep in, sweep out, ya. Di mana yang akan dikerjakan dulu, ya nanti dibalikin lagi, nanti masuk modul selanjutnya untuk bekerja, untuk diproses gitu, ya. Jadi di physical organization ini juga kalau kita melakukan coding, kita tidak tahu tuh, programmer itu tidak akan tahu pasti berapa kebutuhan space dari sebuah proses, ya. Jadi kita nggak tahu, kita mau bikin aplikasi kira-kira butuh nanti plus data itu berapa sih memori yang kita butuhkan. Nah, kita nggak tahu nih kalau kita membuat satu aplikasi. Oke, sekarang kita lihat ini contoh relocation. Jadi, ini CPU, ya. Terus nanti memori itu logical address, jadi alamat logiknya adalah 346. Ya. Nanti di saat masuk ke MMU, ya, Memory Management Unit ini, nanti dia akan dikasihkan relocation register. Ya, jadi nanti dia sweep in, sweep out itu dikasihkan nomor relocation registernya. Jadi nanti dari logical address ditambah relocation register, ini hasilnya adalah physical address. Ya, jadi kalau kita lihat di sini, nanti di physical address-nya si proses itu akan ditaruh di memory address nomor 14346. Jadi ini adalah proses relocation. Oke, sekarang kita lihat protection. Bentar, saya pindahkan dulu. Oke, ini contoh protection. Jadi misalnya ada memori itu 100, ini address-nya ya, terus ini 600 gitu. Ya, protection itu adalah jumlah ini berapa ini? 500. Ya. Jadi memori itu nggak boleh lebih dari 500 ini. Dia lebih kecil sama dengan 500. Ini adalah makanya protection. Jadi bukan lebih dari 600 ini, tapi 500 adalah protection. Jadi kita lihat limit registernya, dicek limit registernya apakah dia masuk di dalam range ini 500 atau tidak. Ya, jika tidak, ya, jika lebih kecil, jika tidak dia nanti akan error itu. Ya, jadi dia masuk ke error, tapi jika dia masuk ke dalam range ini, nanti dia akan tambahin tadi register. Jadi dimasukin, ditambahin relocation register, masukkan nanti ke ini akan dimasukkan, ditambah. Tadi di sini ada tambahan relocation register. Dicek dulu nih sebelum memori proses itu akan dimasukkan ke memori, apakah lebih kecil atau tidak dari 500. Ya, kalau kecil berarti nanti dia bisa dimasukkan ke dalam memori. Ini adalah contoh protection. Oke, sekarang kita lihat untuk addressing. Jadi ada 3 cara untuk address. Pertama adalah logical. Logical ini dia memberi alamat, memberi referensi location berdasarkan alamat logik. Ya, jadi bukan alamat fisiknya si memori. Ya, jadi nanti si logical ini harus ditranslate oleh MMU untuk bisa dapat physical address-nya. Terus yang kedua ini relatif. Ya. Jadi ini biasanya digunakan kalau kita melakukan coding dengan indexing atau indeks kan. Jadi relatif. Terus kalau physical yaitu alamat address fisik dari si memori. Jadi proses itu dikasih alamat fisiknya. Seperti ini saja. Oke, sekarang kita lihat ini programming, monoprogramming without swapping. Jadi kalau kita lihat di sini, kita ini ada proses. Jadi satu proses saja. Jadi monoprogramming prosesnya ada satu. Kalau sekarang kan sudah multi programming, jadi programnya sudah banyak nih yang jalan nih. Proses yang jalan banyak. Tapi kalau kita lihat di sini, ini contoh satu proses yang jalan aja. Jadi ada OS-nya, ada satu program. Jadi kalau kita lihat di sini ada 3 tipe ya. Kalau di mana tidak ada swapping, tidak ada proses yang keluar masuk di sini. Jadi prosesnya jalan terus-terusan aja di sini. Jadi kalau kita lihat mungkin operating system di zaman-zaman awal masih zamannya DOS, itu monoprogramming masih di sini. Ya, kalau program OS yang sekarang udah multiple programming, udah nggak seperti ini lagi bentuknya. Jadi kalau kita lihat di sini, di mana yang A itu adalah OS-nya ditaruh di dalam RAM, di memori, random access memory. Terus nanti sisanya adalah user programnya, jadi aplikasinya ada di memori juga. Jadi ini contoh yang A. Yang B adalah OS itu ditaruh di dalam ROM. Jadi ditaruh di ROM, nanti si user programnya itu baru taruh di dalam memori. Ya. Dengan yang ketiga, ya, yang ditaruh di ROM itu adalah driver. Ya. Jadi driver itu adalah kalau di OS itu instalasi untuk hardware. Ya. Jadi kalau kita install hardware, pengenalan hardware-nya itu adalah drivers. Ya. Jadi driversnya ini akan ditaruh di dalam ROM. Terus di sini user program dan operating system itu akan ditaruh di dalam RAM seperti yang A. Jadi yang bedanya adalah nanti dia akan naruh driver. Jadi setiap nanti OS ini loading, ya OS ini loading, jadi dia tidak perlu driver-drivernya seperti keyboard, mouse itu sudah tersimpan di dalam ROM-nya. Gitu. Jadi ini contoh bagaimana programnya memori ini bisa disimpan. Di dalamnya ada user program dan OS dan driver. Jadi cara organizing memori. Oke, selanjutnya kita lihat jika kita menggunakan multi-programming. Kalau tadi itu monoprogramming yang jadi satu program yang jalan aja, di sini yang multi-programming. Di mana yang A dan B ini bedanya adalah yang A itu input, ya, prosesnya itu multiple. Jadi nanti si memori itu akan dipartisi, dibagi-bagi partisi berdasarkan ukuran dari memori. Jadi ada yang OS 100 kilo, partisi 1 itu 100 kilo, terus partisi 2 itu 200 kilo, partisi 3 itu 300 kilo, dan partisi 4 100 kilo. Nah, nanti si menggunakan yang B adalah prosesnya ini akan ngantri dulu, ya. Jadi akan bikin antrian, dan nanti baru dia akan masuk milih ke partisi mana. Apakah nanti masuk ke A, ke partisi 1, partisi 2, 3, atau ke partisi 4. Ya, jadi dia akan dibikin single input queuing. Jadi antriannya akan dibikin satu aja. Sedangkan yang A itu antrian akan di masing-masing tipe partisi. Gitu. Ya. Oke, Oke. Jadi selanjutnya ini jika kita memori itu swapping ya. Jadi proses kita tahu proses itu masuk dan keluar. Jadi bisa masuk, bisa keluar, dan itu bisa bergantian. Kita lihat ini A sampai G, di mana dari masing proses ada yang masuk, ya A masuk, nanti B masuk, C masuk, nanti A keluar, B keluar, D keluar, D masuk, seperti itu. Jadi ini adalah di mana sebuah proses masuk ke dalam memori. Tadi yang A itu proses A masuk, nanti di B-nya itu proses B masuk, C itu di mana proses C masuk, ya, dan di D proses A itu keluar. Ya. Terus di E masuk lagi proses baru di tempatnya proses D, ya, itu nanti dia ada ukuran prosesnya ternyata lebih kecil dari A. Ya. Terus nanti di B yang di F itu B-nya keluar. Ya. Nah, nanti B digantikan oleh proses A. Jadi ini adalah proses di mana memori itu swap in, swap on. Jadi di sini kita lihat ada beberapa, kalau kita lihat di gambarnya, kalau gambarnya garis-garis itu ya, itu adalah memori yang tidak digunakan, jadi nggak terpakai. Jadi kalau kita lihat di E, di mana ada proses, ada memori yang tidak digunakan lumayan banyak. Ya. Jadi ini kita sebut sebagai fragmentation. Jadi ukuran memorinya harusnya besar gitu, ya, kapasitasnya, tapi nanti digunakan sedikit. Nanti kita lihat ada contohnya. Oke, ini proses swapping kedua, ya, di mana memori itu bisa nambah berkembang karena di dalamnya nanti ada data, ada stack. Ya, kita lihat nih yang A. Jadi actually penggunaan actual use-nya adalah setengahnya dari memory allocation yang untuk A. Sedangkan B juga setengahnya. Nah, nanti di gambar B, di mana ada room for growth. Jadi ada sisa ruangan untuk A bisa berkembang. Jadi di sini setelah program A ini dimasukkan data dan stack, ya nanti ada sisa nih. Itu adalah ruangan untuk bisa ditambah, ya, untuk memori di A. Itu juga yang B sama. Jadi program nanti ada data, terus ada stack. Nah, dari antara stack dengan data ini ada space nanti yang bisa digunakan, ya, untuk proses file atau untuk data lah biasanya. Oke, sekarang kita lihat bagaimana memori manajemen. Ini ada dua sini. Yang sebelah kiri itu adalah memori manajemen dengan menggunakan bitmap. Ya. Jadi yang bitmap itu kan 1010 ya, bilangan biner. Jadi kalau dia 1 berarti memorinya ada isinya. Ya. Sedangkan kalau 0 itu berarti memori space-nya itu kosong. Ya, jadi kalau kita lihat yang 1111000 ya, berarti ada 5 bit memori yang berisi dan 3 yang kosong. Ya. Sedangkan gambar yang kedua itu sama ya. Jadi kalau yang ini adalah menggunakan bitmap, ya. Sedangkan yang ini menggunakan linked list. Ya, kalau kita lihat sama aja sebenarnya. Ya. Kalau yang linked list itu di mana P itu adalah proses, all ini adalah memori yang kosong. Jadi kita lihat P05 maksudnya adalah proses dimulai dari alamat memori 0, ya, ada 5 bit ke situ, 5 bit yang dipakai. Ya. Sedangkan hole-nya berapa? Hole-nya itu mulai dari alamat nomor 5 ke gesernya yang kosong adalah 3 bit. Seperti itu sama. Jadi ini contoh menggunakan bitmap atau menggunakan link list. Ya. Tapi lebih enak sebenarnya kalau kita menggunakan bitmap sebenarnya lihatnya, lebih gampang gitu. Karena ini yang link list proses, terus ada hold-nya, proses lagi, ya, nanti baru cek hold-nya. Jadi agak butuh effort lah kita ngecek kosongnya di mana nih memori yang bisa dipakai. Ya. Kalau kita menggunakan bitmap, kita lihat aja yang 000 itu berarti itu kosong tuh. Jadi ada 3 bit space yang kosong di situ. Ya. Oke. Oke, sekarang kita lihat memory partitioning. Jadi ada beberapa cara kita mempartisi memori, kita bagi-bagi memorinya. Mulai dari fixed partitioning, di mana partisinya itu kita akan bagi secara fix, ya, jumlahnya tetap. Yang kedua dynamic. Nah, ini bisa tergantung ukuran prosesnya. Ada simple pegging, simple segmentation, virtual memory pegging, virtual segmentation. Ini untuk di slide ini kita nggak bahas. Jadi total ada 6 memory partitioning. Yang kita bahas ini adalah fixed partitioning dan dynamic partitioning. Oke, sekarang kita lihat di sini yang fixed partitioning. Jadi ada memori itu kita bagi menjadi 8 semuanya. Jadi ada semua memori itu kita akan bagi menjadi partisi-partisi 8 mega semua. Jadi si proses nanti harus bisa menyesuaikan ukurannya. Ya, kalau dia misalnya prosesnya di bawah 8 mega nggak ada masalah di sini, ya, bisa masuk, bisa dijalankan. Tapi nanti kalau misalnya dia lebih dari 8 mega, ya mungkin nanti ada beberapa teknik, ya, contohnya menggunakan overlay itu, ya, supaya proses itu bisa dijalani. Jadi misalnya prosesnya kebutuhan memorinya adalah 10, ya, nanti dilakukan teknik overlay ya, untuk bisa tetap muat di dalam partisi yang fix ini. Gitu. Oke. Terus kita lihat di sini. Ya, contohnya misalnya kita punya saya gambarin dulu. Nah, ini tadi 8 mega, 8 mega, 8 mega, mega, ada begitu. Di atas ini OS. Ya. Terus di proses 1 masuklah ya, proses butuhnya misalnya mega. Nanti di sini dipakai ini. Terus yang kedua jalan 8 mega. Ini full paket. Terus P3 ini 2 mega. Jadi segini baru. Jadi yang kosong-kosong ini, ya, yang kosong-kosong yang aku pakai, ya, di sini, ya, di sini ini itu kita sebut sebagai internal fragmentation. Jadi di mana ada yang tidak yang sisa yang digunakan oleh sebuah proses. Jadi sisanya, misalnya ini berarti sisanya ada 2 mega ini. Ya, sedangkan ini sisanya ada 6 mega. Jadi 2 mega dan 6 mega ini adalah internal fragmentation di situ. Jadi ini mubazir sebenarnya. Jadi kalau dia fixed partitioning, banyak nanti space yang mubazir yang nggak bisa digunakan. Jadi nanti ada memori yang lain atau proses yang lain. Padahal kalau dijumlahkan itu jadi 8 mega nih sebenarnya. Jadi nanti ada kita bisa menggunakan namanya dynamic partition. Jadi kita fixin ukuran memorinya. Jadi kita bikin dia dynamic, ya. Tergantung ukuran prosesnya. Oke. Jadi contohnya di sini. Jadi di situ di mana ada memorinya kita bagi-bagi berdasarkan unequal size. Ya, ini bukan dynamic, masih unequal. Jadi kalau ini fix 88, jadi kita bisa bikin dia size-nya nggak sama. Ya. Jadi nggak 8 semua, bisa ada yang cuma 2 mega, ada 4 mega, ada 6 mega. Ya. Jadi nanti jika program atau proses itu ukurannya adalah 16 mega, dia nanti bisa masuk ke dalam size yang 16 mega. Jadi dengan unequal size, jadi kalau ini tadi size-nya sama semua, ya, menghindari terjadinya internal fragmentation, ya, dan memori overlay, ya kita bisa bikin dia menjadi unequal size partition. Ya. Jadi ukurannya nggak sama, nggak 8 mega. Tapi ini masih tetap fixed partition. Jadi partisinya masih fix. Ya. Tapi dia bisa mengurangi internal fragmentation. Jadi nanti si proses ini akan masuk sesuai dengan kapasitas dari memorinya. Jadi dia akan disesuaikan. Jadi fragmentation-nya nggak terlalu seperti ini nih, 6 mega. Ya, jadi bisa dikurangi di situ. Itu yang unequal size partition. Oke. Terus kita masuk yang dynamic. Ya. Jadi dynamic ini ukuran partisinya itu bisa berubah-ubah tergantung nanti ukuran dari proses. Jadi berapa ukuran prosesnya, nanti baru partitioningnya mengikuti dari proses ukuran dari proses tersebut. Jadi kalau kita lihat ini yang A itu pertama ada free space 56 mega, nanti masuk satu proses itu 20 mega, di size-nya itu akan bisa 36 mega. Masuk lagi proses kedua itu 14 mega, di size-nya jadi 22 mega. Lanjut masuk lagi proses 3 18 mega, di size jadi 4 mega. Ya. Terus di sini tiba-tiba proses 2 selesai. Ya. Jadi proses 2 keluar, tersisalah di space 14 mega dan 4 mega. Nah, di 14 mega ini masuk proses proses 4 yang mana ukurannya hanya 8 mega. Ya, berarti di space-nya yang tadi 14 mega ini akan ada free space lagi 6 mega. Ya. Terus di selanjutnya yang satu keluar, ya, ada free 20 mega. Ya. Terus proses 2 masuk lagi. Ya, dia akan mengisi di tempat di mana proses 1 tadi keluar. Ya. Ukurannya itu 14 mega. Nanti ada free lagi di tempat tadi itu 6 mega. Ya, kalau kita lihat di sini ada 6 mega, 6 mega, 4 mega. Itu free. Ya. Ini free ini adanya di mana? Di internal space-nya atau di luar space? Ya. Di internal memory space partition-nya atau di luar yang free-nya? Jadi sini kita lihat nih, ada 6 mega, 6 mega, 4 mega. Seandainya ya, ada program ukurannya 8 mega, kira-kira bisa masuk nggak di sini? Bisa jalan nggak? Prosesnya bisa diakomodir nggak di sini? Padahal kalau kita hitung free space-nya kan 6 mega, 6 mega tambah 4 mega, itu ada 16 mega. Ya. Ada proses butuh cuma 8 mega. Ya. Kira-kira bisa diakomodir nggak di sini? Untuk di sini? Halo? Gimana? Bisa diakomodir nggak? Ya bisa ya. Jadi yang sisa-sisa space tadi itu adalah external fragmentation. Jadi dia berada di luar fragmentasi ininya dia apa space-nya tadi. Kalau ini kan 8 mega partitionnya, ya. Tapi kepake cuma 2 mega. Ini kan internal. Kalau tadi ada di luar dari fragmentation-nya dia, itu kita sebut sebagai external fragmentation. Nanti kita bisa bikin dia naik tuh. Jadi space-nya kita bisa lihat, kita bisa sorry. Ini contoh aja. Ya. Jadi yang kosong-kosong tadi, yang empty ini kita bisa resolve tuh supaya tidak external fragmentation. Ya, namanya menggunakan compaction. Jadi nanti digeser-geser nih, jadi proses P4 itu akan dinaikin ke atas, ya, P3 naikin ke atas, ya, sehingga nanti akan ada free space sekitar 16 mega. Tapi problemnya adalah ini time consuming, ya. Jadi terus CPU time-nya juga akan waste, ya, kita akan membuang CPU time di sini. Jadi kalau kita menggunakan compaction ini ada kelemahannya. Yang pertama itu waktu, ya, terus nanti waste CPU time. Itu kalau kita menggunakan compaction. Oke. Sekarang kita lanjut algoritma untuk placement memori, ya. Jadi bagaimana kita algoritma untuk memory allocation. Ya. Jadi ada 6 di sini. Ya. Pertama adalah first fit, next fit, best fit, worst fit, quick fit, dan body system. Ya, jadi kita lihat dulu first fit. Di sini best fit dulu. Ya. Jadi best fit itu adalah di mana nanti kita akan memasukkan proses, ya, ukurannya closest dengan size dari memorinya. Ya. Jadi ini dia akan cek dari atas sampai ke bawah, di mana nih yang kira-kira proses ukurannya akan mendekati dari ukuran proses itu. Ya. Itu adalah best fit. Terus yang selanjutnya first fit. Jadi first fit itu dia akan scan, ya, mulai dari atas sampai bawah. Nanti kita lihat gambarnya nanti contohnya. Dia akan scan yang available pertama kali mana nih ukurannya. Jadi misalnya dia scan dari atas ke bawah, pertamanya ada 8. Ya, dia butuhnya cuma 6 misalnya 6 mega. Ya, dia scan dari atas. Di atas ini space-nya 8, bisa 6 mega kita masuk. Nah, ini kita sebut sebagai first fit. Ya. Ya, kita lihat contohnya, kalau next fit itu nanti ada placement location-nya dari last placement. Jadi nanti ada terakhir placement-nya di mana, contohnya. Jadi nanti dia mulai scan-nya dari sini ke bawah. Itu next fit. Nah, kita lihat ini contohnya. Jadi ini memori ada ukuran 8, 12, 22, 18 dan sekian. Ya. Terus yang last allocated block itu terakhir nanti ya, untuk next fit di 14K di situ. Nah, nanti kebutuhan memorinya adalah 16 megabit space, ya. Jadi kebutuhan memorinya adalah 16 mega. Kalau kita menggunakan first fit, dia akan search dari awal. Dia akan search di 8 itu nggak muat nih kalau 16 mega. Terus dia turun ke 12. Di 12 juga nggak muat kalau kita kebutuhannya 16. Lalu turun ke bawah, ketemu di 22. Berarti di 22 kita bisa masukin nih nanti 22 masuk, sisanya adalah 6 mega di sini. Jadi ada free space-nya setelah kita masukkan 16 mega itu adalah 6 mega. Jadi dia cek space mana yang kosong dan bisa masuk, itu adalah first fit. Sedangkan kalau best fit ya di 22 wah sisanya 6 mega kebesaran nih. Ya. Dia turun lagi ke bawah, ada 18 mega. 18 mega ini bisa masuk di sini ya, dan nanti fragmentation-nya ya cuma 2 mega kecil. Ya. Jadi di situ masuklah best fit. Ini adalah algoritma menggunakan best fit. Terus yang next fit bagaimana? Next fit itu dia akan mulai akan scan dari last allocated block. Last allocated block-nya adalah di blok 14K di bawah 18 tadi. Ya. Jadi ada itu nanti dia akan scan ke bawah. Ya. Jadi di scan pertama 8 mega nggak muat, 6 mega nggak muat, turun ke bawah 14 mega masih nggak muat. Ya. Berarti yang muat ada di 36 mega. Masuklah dia memori itu di 36 mega. Misalnya adalah 20 mega. Jadi mulainya adalah dari terakhir allocated block-nya itu adalah next fit. Selanjutnya adalah body system. Ya, jadi body system ini menggunakan 2 pangkat view, ya, 2 pangkat 1, 2 pangkat 2, ya berdasarkan ukuran memori. Ya. Jadi kalau kita lihat gambarnya, nih saya gambar dulu. Jadi kita punya memori itu 1 mega. Ya. Kalau sekarang 1 mega kecilan ya. Jadi di sini ada kebutuhan 100K pertama. Jadi nanti 1 mega ini akan dibagi 2. Ya. Jadi kan 2 pangkat N. Ya. 2 pangkat berapa tuh? Bisa dibagi 2. Kan ini 512, ini 512. 512 juga kalau untuk 100 kan kebesaran. Ya, masih terlalu besar nih begini. Jadi 512 kita bisa bagi 2 lagi. Bagi berarti 256, 256. Untuk 100 kilo, 256 masih terlalu besar juga. Ya. Ini terlalu besar nih. Kita bisa bagi 2 lagi, 256. Ya, 256 kita bagi 2, itu 128. Ya, 128. 128 untuk 100 kilo cukup ya. Jadi, nanti di sini masuklah ya 100. Fragmentation-nya berapa? Fragmentation-nya berarti ada 28. Ya. 28K. Terus request kedua adalah 240K. Ya, 240K. Ini sisa 128. Ini masih 256 nih. 256 butuhnya berapa? 240. Kita masuk sini ya. Berarti nanti si B masuk ke sini. 240. Berarti yang nanti ada sisa 16. 16K nih. Terus yang C lanjut adalah kebutuhannya 64 kilo. Ini sudah keisi. Ini sudah keisi yang 256, berarti tinggal ya 128. Ya. 128 juga terlalu besar kalau kita butuhnya 64. Tapi ini bisa dibagi 2 lagi nih. Ya. Dibagi 2, tapi ini masuk ke C. Ya. 64. 64. Oke. Ini contoh bagi sistem. Terus yang selanjutnya adalah butuh 256. Berarti ini 0 ini. Butuh 256. Ini sudah penuh, ya, sudah diisi, sini sudah diisi. 256 di sini, tapi sudah diisi, ya, sudah dipakai. Berarti kita ambil porsi yang di sini, menjadi 512. 512 sudah terlalu besar kan? Kita bisa bagi dia menjadi 256, 256. nilai yang di sini. Ya. Misalnya implementasinya 0. Berarti sekarang yang kosong berarti tinggal ini sama yang ini. Lanjut, selanjutnya adalah B release. Ya. Jadi B dirilis, dan B-nya keluar di sini. Ini kosong. Selanjutnya adalah A yang rilis. A rilis. Ya. Jadi A rilis, ini kosong. Jadi, terus masuk C, masuk D, E itu 75K. 75K masuk nggak di sini? Di tempat nggak bisa, ini kan 256 tadi ya. Ini 128. Tapi kalau 75 muatnya ada di sini kan? Masuk yang E. Ya. Selanjutnya C dirilis, ya. Ini C rilis karena dia nanti ini namanya body system. Ya, nanti kita lihat gambarnya biar lebih tahu, biar lebih mudah. Ini nanti dirilis jadi 4 tambah 4 jadi 128. Ya, 128. Terus E rilis, yang E dirilis ini kan free, ya. Nah, udah free, ini dihapus jadi 256. 256 setelah itu kayak dirilis, ini free, ini bisa dihapus lagi. Ini jadi 5, 12. Terakhir D dirilis. D dirilis ini jadi sama free sama lagi. Jadi 1. Jadi kalau body system, ya, yang dimaksud body system adalah saat kita fragmentasi dia. Ya, kita bagi 1 mega dibagi 2. Ya, ini chartnya ya. Jadi 1 mega kita turunin chartnya 512. Nah, ini adalah body system nih. Ya. Ini yang kiri kanan ini adalah sibling ya, body system. Nah, nanti kalau 512 kita bagi 2 lagi. Jadi 256. 256. Nah, ini adalah body systemnya. Ya, jadi siblingnya ini. Ya, dengan ini bukan body system ya. Jadi yang sebelah sini dengan yang sini, yang 256 dengan 512 itu bukan body system. Yang body system adalah dengan yang ini. Jadi kalau kita bagi range 128 ini adalah body systemnya. Jadi yang ini dengan yang ini bukan sibling, ya, bukan body systemnya. Jadi kalau kita mau mudah sebenarnya kita lihat gambarnya berdasarkan tree representation. Nah, kita lihat parentnya siapa sih? Ya, jadi parentnya ini 128 dengan 128, parentnya yang mana? Yang 256 itu. Jadi dari sini kita kelihatan mana yang badinya. Ini adalah gambaran menggunakan tree representation. Oke. Dari sini ada pertanyaan? Karena kita sudah selesai. Ada pertanyaan mengenai memori manajemen? Ada pertanyaan? Saya baca chat dulu. Chat. Oh, tidak. Ada pertanyaan? Oh, ini yang mana nih penggunaan sistem itu digabung? Yang mana yang mau digabung? Yang body system ya? Kira-kira misalnya yang ini digabung dengan yang ini. Maksudnya begitu. Jadi kalau apakah sistem salah satu implementasi? Enggak. Nanti bisa berbagai macam. Tergantung nanti kita mau mau develop OS-nya kayak gimana. Ya. Jadi ini gambaran basic aja, dasar. Nanti kalau kalian mau bikin OS atau OS sekarang itu bervariasi. Jadi contohnya body system ini dipakai di Linux. Nanti dia kamu mau bikin OS lagi menggunakan Linux, kamu coding lagi, kamu bikin OS baru, kamu bisa variasiin tadi. Bisa pakai fix ini beberapa teori dasar ini kamu gabungkan, ya, kamu enhance lagi, itu bisa. Ya. Jadi tergantung pengembangnya. Ya, ada lagi? Ada pertanyaan lagi? Jadi ini kita belajar teori dasar aja ya. Jadi, body system isi 256K, isi oke, saya gambarin dulu. Saya gambarin 256. Ini berapa nih ukurannya? Kita anggap 1 mega ya. Kita bagi tadi 512, terus 256K isi. Berarti ini 256. Ini isi. Terus 128K free. Ini free. Terus 256K kosong. 256K kosong. 64 isi. Oke. Atau di sini isinya. Gambaran gitu. Ini mana? Oh, kayak begini, gambarnya kayak gini bukan? Ya. Jadi 256 itu isi, ya. Terus 128 kosong. Nah, ini 128 kosong tadi kita isi di sini. Ya, awalnya kosong, ini kita isi. Kamu kalau kosong, kalau kayak begini, nah efektif. Terus 256 kosong 64 isi 4 isi 4 kosong 128 256 ini kosong ya, ini isi. Terus mau masuk 270 ya, pertanyaannya begitu. Pertanyaannya begitu. Kalau 270 itu nggak bisa, apakah pisah lokasinya? Nggak bisa. Tapi kalau begini nggak muat ya. Jadi bagusnya adalah kosong ini tadi 64 masuk di sini. Ya. Kamu bagi di sini nih 64 nih. Ya. Kosong berarti ini nanti di sini diisi di sini pindah ke C. Ya. Terus berarti yang di sini ini. Dia ada free di sini nanti. Kamu 28-nya kosong. Oke, ini kosong. Ini kosong. Jadi ini 26. Nah, ini bisa dibuka nih. Ini kita free. Kita free 512 di sini. Baru bisa masuk yang 270. Jadi pengaturannya kayak begitu. Ya. Oke. Jadi jangan yang penting jangan di sini. Supaya nanti 270 bisa masuk ke dalam 512 yang kosong. Oke. Ada lagi? Sudah lewat waktunya. Sudah jam 11 lewat. Oke, kita akhiri sampai di sini. Nanti detailnya kalian bisa tanya di kelas kecil ya. Untuk penghitungan ini atau pertanyaan lain bahkan di kelas kecil. Oke, saya akhiri sampai di sini. Selamat siang semuanya.
Makasih Pak.
Makasih,
Siang
Pak.
Pak. Makasih.
Makasih Pak.
Makasih, Pak.
Makasih Pak.
Terima kasih, Pak. Terima kasih banyak, Pak.
Makasih, Pak.
Yuk.
Pak.